Hi everyone, let's work through problem 10-8, which deals with net present value and internal rate of return. And it has a couple little twists to this problem. We're dealing with the Cummings products, and they're considering two mutually exclusive investments. The project's expected net cash flows appear below, and we're asked to solve these 5 requirements. Okay, down below I've just repeated the information that we have here, and then I've computed the difference or the delta between the two projects and laid that out as well. In Part A they say construct NPV profiles for projects A and B. Okay, let me slide down so you can see this. Okay, so what I've done is just pick some rates. I started off by going 5% differences, and then as we worked through some of the problems at the end, I saw that it made sense for us to compute some numbers in about the 15 to 20% range, so I dropped those in as well. Okay, so let's compute NPV for under these various scenarios. So let's do NPV A of here and NPV for project B here. And let's just drop it in. NPV would be equal to that rate. Now we need to copy this, so I'm going to just lock in column B, which you do it that way. And then the values, we start from year 1 through year 7. And I'm going to lock both of those in, right? But then we also have to add in the negative, if you will, in the first period. And that occurs right now, so we don't want it to assume it occurs at the end of year 0, right? So to do that, I show that as an addition at the end of the formula. Okay, there's a couple things we need to change on this formula. One is it's relative referencing on cell C24. And if I copy this down, I always want it to go from on row 24, so I'll put a $sign in there. So we'll take care of that. Also, I've indicated that it's always B, and in the range always in column C, and that's not true. I want that to be relative as well. So I really am just concerned that it's in 25 to 31. And that should take care of that. And let's see now if that copies correctly. There we go. Okay, so now we've put together the NPV profile that you can see on your screen, which is nothing more than telling us what's the net present value at various interest rates for both projects. Alright, now let's do IRR. Now IRR is very simple. Just use the financial function IRR, give it the range. Right? Let me lock that in. Equal IRR. Okay, and indicate the values. Just by doing that, give it a guess. I like to use 10%, and we come up with that. Copy it there, and we've determined that the IRR for project A is 18.1%, and for project B it's 24%. Now we look at part C, which says if you were told that each project's cost of capital was 10%, which project should be selected? Well, clearly at 10%, if I highlight that range right there, you see that Project A has a higher net present value than Project B, so we would select Project A. Now we turn around and we say, what happens at 17%? Well, at 17%, the reverse is true. Project B has a net present value of 76, where Project A has one of 31. Okay, now let's compute the modified internal rate of return, and I'm going to use the Excel's function on that. So I'll do an equal MIRR left paren. I'll hit my formula so we get the pop-up on this one. The values are that range of cash flow, right? And with the finance rate, what are we asking for in the question? At 10%. So let's just go to where we have 10% entered, and the reinvestment rate is that same 10%. Okay, so if I calculate, I get 14.1% for project A. I'm going to copy this here, but we need to modify a couple cells. Let me hit the formula here. Because it's going to C35, I really wanted that to be B35 for the 10% rate. So why don't I just go point to that again. That needs to be B35. And if I cut and paste, we'll get that. And so we have 16.9% as the modified internal rate of return at 10%. Okay, and then in Part D, let me slide up so you can see a little bit more on that. In Part D, they've said, what's the MIRR at 17% now. So now we want to change that again. Let's point to that formula again. The range we want to give it is right there. Now we're going to use a 17% range. Put B37 in here. Make that B37. Okay, I'll do the same thing here. We'll get a funny number first because I have C37. We'll change that to B37 to give us the 17% value. Change that to B37 as well. And now we can see that modified internal rate of return gives us a few different numbers, and based on whether our cost of capital is 10% or 17%. Okay, now finally we're asked in Part E, what's the crossover rate and what is its significance? Well, the easiest way to determine the crossover rate is to calculate the difference between Project A and Project B, which I've done here, excuse me, and then use internal rate of return to determine what that internal rate is. Okay, so if I use IRR, why don't we hit the F2 to bring up the formula? I'll slide that over so you can see it. That's the range right there. Again, just use a 10% guess. I'll pull it from cell B35. And we get a 14.5% internal rate of return for the delta, which means the crossover rate. Now, let me show you graphically what that looks like. Let's just highlight this 3 range here, do an insert, a chart. I know you can't see all of this. Do a scattergram. Hit next. The data is on columns, so that's fine. I will hit next. Actually, I don't care about any of that for purposes of this. Let's shrink this down just so we can see it on the screen. And then what I'm going to do is add a trend line, in this case a polynomial, so we can see the curve. And I will add the trend line here, also a polynomial. Nomial, I think, is the correct way to say that. And what you'll see, I know it's a little bit hard to see because we don't have a lot going on here. Let me get rid of this. Maybe we'll get the graph a little bit bigger. Slide this over a little bit. Let's see if we can make this just a hair larger. Okay, and you see that the crossover rate really is at about that 14.5%, and it's where the NPV profiles, we can draw a line based on the results at various interest rates. Interest rates are the x-axis, and the NPV is on the y-axis. And the crossover rate, which we calculate as 14.5, appears right about there, just where we'd expect it on the graph. Okay, everyone.